For Lesson 9.4, we're still solving quadratic equations, but with a different method using our square roots. So when they say x squared equals 49, we're saying what number times itself makes 49? Well, you may say, hey, 7, because 7 times 7 is 49. That's what squaring means. Remind yourself that something times itself is what we do when we square a number. We don't divide by 2, which is a common mistake. But we also have to remember a negative 7 times a negative 7 would make 49. So we could say x equals 7 or x equals negative 7. Sometimes we can write that as x equals plus or minus 7. Another way to think about this is when you have a squared power, the inverse or opposite operation would be square rooting. When you take the square root of 49, it's not just a positive 7, but it could be a negative 7. For part B, if we square root a negative 121, your calculator will give you an error. And that's because a number times itself will never come out negative. Recall, a negative times a negative would make a positive, and so would a positive times a positive. 11 was going to be our choice, but this negative sign here threw us off, so this one would have no solution. Now, sometimes we get so far into solving, we forget what we're finding. Both of these equations, solving them, tell us that the solution means this is the x value where this quadratic would hit the x-axis. And by the quadratic, I mean x squared minus 49. If I subtracted 49 from both sides, this parabola would cross the x-axis at 7 and negative 7. Whereas the parabola x squared plus 121, if I solved it for 0, this would never cross the x-axis. That's because it has a y-intercept of 121 and it's opening upwards. So if I had 121 as my y-intercept and it was opening upwards, it's not going to touch the x-axis. Part B down here will have a similar thing happen because no number squared equals negative 16. But this one would work if we square root. We would get the positive or negative 13 as our answer. Example 2 brings more of the same, but now we have a number out front. We have an a value. So if I were to divide by 7 first on both sides, it would bring my number down. I would have x squared equals 16. And we've seen this before. If we square root both sides, we'd have x is plus or minus 4. That means if we would have put this in a standard form, the quadratic 7x squared minus 112 would equal 0 or have x-intercepts at 4 and negative 4. Same thing here. We could divide by negative 3 first, which helps us get rid of that negative. And x squared equals 8. This time, if you took the square root of 8, it's going to give you a decimal. And we can just leave it at that. Let's go look at what our graph looks like for a second here. But not every parabola is going to cross at really nice whole numbers. Any parabola you'd graph, say with your eyes closed on a grid, probably is going to cross at a decimal answer. So if we took the square root of 8, we get approximately, we could say plus and minus still, but 2.83. Now, if we go look at Desmos here, we're going to graph that quadratic. And remember, we would use the negative 3x squared plus 24 if we moved it all onto the same side. So we have negative 3x squared plus 24. And when we look at the x-intercepts, it is crossing at that plus 2.82 and the minus 2.82. So for now, let's leave it as those decimals. If you ever take the square root of a value and it comes out with decimals, just don't forget the plus and minus. On your charts, B might look a little frightening to you, but you can just divide by a negative half, and a negative divided by a negative is a positive, and we would have a 72 equals x squared. This one, again, is not going to come out as a whole number, so we could just put x is approximately plus or minus, don't forget that, 8.49. That would be where the parabola negative 1/2 x squared plus 36 crosses the x-axis approximately. Now again, when you're trying to solve a quadratic, it's always important to get everything on the left side if you're factoring. But notice how we're missing our b term. We don't have any x values. When that b value is a 0, we can just keep solving like we would a linear equation. So let's add 5 to both sides and we get 27. We'll divide by 3 on both sides, and x squared will equal 9. We know that 3 times 3 is 9, and so is negative 3 times 3. That means our quadratic of originally would have been 3x squared minus 27 equals 0, and it crosses the x-axis at 3 or negative 3. One final little solve here. We could go ahead and add 19 to both sides here. Maybe. So if I add 19 to 144, 163, and now if I divide by a negative 5, so there's two concerns here. First of all, when I take 163 divided by 5, it's a decimal answer, but it also is a negative. We know from our last section or two here that when you square root with a negative, it's going to give us an error. So this parabola or quadratic has no solution, or no real solution, we could say for now. That means if you had the quadratic negative 5x squared minus 163, it would not cross the y-axis.